So, in this video, I will teach you how you can convert decimal, binary, octal, and hexadecimal, and vice versa. So, let's get to it. First, let's use decimal to convert it vice versa. So, let's convert decimal to binary. So let's have an example of 89 decimal in decimal form. How we can convert it to binary? First, let's divide 89 by 2. 89 divide 2. You can get 44.5. Instead of putting the 0.5, you can only use 44 and multiply 5 by 2, and that's what you get here. You get 1. So divide 44 again by 2, and that's equals to 22. Since there is no point here, you can just put R0. 22. Divide 22 again by 2, so you get 11. Again, there is no, so you got to put 11 or 0, and divide again. 11 divide 2, you get 5.5, so you put 5 here. 0.5 times multiply by 2, you get 1. 5 divide 2 again, you get 3.5, so 3 multiply 0.5 by 2, get 1. 3 divided by 2, so 1.5 multiply 0.5 again by 2, get 1, get 1. 1 divided 2 again equals 0.5. Multiply 1.5 by 2, and from here we will take from down to up, so we get 1 1 1 1 0 0 1. So the binary number of decimal 89 is 1111001, and that's how you can convert a decimal to binary number. And next, let's convert decimal to octal. Let's have a decimal number of 89 again. So we can convert decimal to octal by just simply doing the same process as from decimal to binary, but instead of using 2, we will use 8. So let's divide 89 divide 8, we'll get 11.125, and we'll copy again 11 and divide and multiply 0.125 by 8, so we get 1. And 11 divided by 8, we get 11.375. 1.375. Let's get 1, and we have a round of 0.375 multiplied by 8, that's equals to 3. And 1 divided by 8 is 0.125. So we'll copy 0 and multiply 1.125 by 8, we get 1. And from here, from bottom to top, we have 1, 3, 1. That is the octal number of decimal 89. And now let's convert decimal to hexadecimal. Decimal to hexadecimal. Let's have an example of decimal number 89 again. Again, it's just the same process, but in hexadecimal we use 16. We divide 16. So 89 divided by 16 is 5.5625. So the same process, 5 multiply 0.5625 by 16, we have 9. And 5 divided by 16 is equals to 0.3125. So we got 0 and 0.3125 multiplied by 16 is 5. So from bottom to top, we have 5 and 9 as the hexadecimal number. In hexadecimal, you have 16 numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and here you have 10 numbers. After that, you will use an alphabet: A, B, C, D, E, F, which corresponds to 11, 12, 10, 11, 12, 13, 14, 15, and 16. You have to keep in mind this. If you have for example, R13 here, you will use, instead of 13, you will use D. So that will be 5D, for example. That's how you can convert decimal to hexadecimal. So next, let's convert binary number to decimal. Let's have an example of 1, 0, 1, 0, 1, 1. So in binary, since there are only two numbers, you can convert them into decimal by using this. This is 2 to the 0 power, the first number. The second number is 2 to the first. The third number is 2 to the second, 2 squared. The fourth number is 2 cubed. The fifth number is 2 to the fourth power, and so on. So 2 to the fifth power, we will add them: 2 to the fourth, 2 cubed plus 2 squared. So let's get their values. 2 to the fifth is 32. And 16, 8 plus 4, 2, and 1. So we will only add the values that are 1. The 0, we will not include them, only the ones. So 2 to the 5th power 32, we can add it. 2 to the 3rd is 8 plus 8. 2 to the 1st is 2 plus 1. So the answer, will add them. 32 plus 8 equals 40 plus 3, we have 43 sa base 10 system. So the decimal number of binary is 43 base 10 system. So next is we can convert binary to hexadecimal. And we will try to convert also. We will use binary to decimal to check if the hexadecimal is correct, which is we will also convert hexadecimal to decimal. So let's have an example of 1 0 1 1 0 1 1 1. So hexadecimal is a base 16 system. We will divide it into 2 groups. Every group has 4 numbers in it because the values are, of course, 2 0 2 1 2 squared 2 cubed. And if you add these numbers, there, that's 1, that's 2, that's 4, and that's 8, you will get 16. You will get 16 if you add all those numbers. That's why you can only group it by 4. So let's continue. 2 0 2 1 2 squared 2 cubed, and let's get there. 1 2 4 8. So we will add only the ones and we will ignore 0. So in here, in this group, we will have 8 plus 2 plus 1, and this group is, we have 4 plus 2 plus 1 there. If we add this, we will have 11, and if we add this, we will get 7. So since it's hexadecimal, we can't use 11, instead 10 equals to A, 11 is equals to B. So we will have to use B instead of 11. So the hexadecimal of binary number 10110111 is B7 base 16 system. So we will try to convert this binary system to decimal to check if our hexadecimal is correct. So 10110111, we will get their values. So this is 1, this is 2, this is 4, this is 8, but we will, as again, we will ignore 0, so let's erase that. This is 16, this is 32, this is 128. So we'll add them. That will be equals to 183. So this is the decimal number of this binary number, and we will convert it to from decimal to hexadecimal to see if our answer is correct, if it's the same. So we have B and 7. We will use 16. We will multiply these values to 16. 16 to the nth power. So first, since B corresponds to 11, we will use 11 times 16. Since this is 16 by 1, 16, 0. 16 by 1. Let's add them to the product of this number. 7 times 16, 0. So 16 by 1 is 16. So let's multiply 11 times 16. We'll get 76. 176. And this, since 16 is equals to 1, 7 times 1 is 7. We will add them and we get 183. So this is the decimal number of hexadecimal B7. That's how you can convert them. And lastly, let's convert binary number to an octal number. So let's have an example of 110101. Octal has base 8 system, so we will we will group it by 3 numbers. As I said earlier, this is 20, 21, 2 squared. Their values are 1, 2, 4. So that equals to 7 since we are using only octal. So let's continue. 20, 21, 2 squared, 1, 2, 4. Again, we will ignore the zeros and continue with 1. This is 1 plus 4. This is 4 plus 2. We will add them. This is 6 and this is 5. So that's the octal number of 110101. 6, 5.